Okay, I'm going to continue to solve the number 6 of GCRA from the year 2016 fall. We're given to the incoming freshmen before they're taking the Chem 1 exam. We just want to know where you're standing. So once again, let's solve these numbers. Okay, number 6 is assuming which assumption the original Dalton's atomic theory, which is a postulate about the atoms and can be revised, and that the first one is actually incorrect and it has to be revised, and because if you're looking at the isotope, which is we just talked about in the problem 5 before, isotope has a different number of neutron, but we call that the same atom, right? So although it's the same atom, they can have a different number of neutrons, right? So all the atoms in a given element, with the element periodic table, are all alike in all respects. That's not true, because an isotope, they have a different number of neutrons. So A is an incorrect statement. Number 7, we're going to solve it, which is these are the notations that you see, and then this is just putting a random letter symbols there. So I'm gonna write it one more time. That's the letter symbols, and what you see on the bottom here, that's a P, number of proton, and also we call it an atomic mass, atomic number. Whereas atomic mass is N plus P, number of neutron and number of protons together. So if you look at that, 124, they are the same atom, which is the same number of protons. So that's the same atom. So, and these are the different number of neutrons we can calculate from by subtracting the atomic the number on the top, which is we call the atomic mass, subtracted by the atomic number, which is the number of protons, and you can calculate the number of N. At any rate, they are asking that what is the same element, just a different isotope, and this is a 1 because they have the same number of protons. So A and the Z is the same one. Okay, so this number 8 is actually natural abundance of the atoms. If you're looking at the periodic table, actually the mass is given as an average quantities. The lithium, which is atomic number 3, has an atomic mass of this AMU, which is AMU is atomic mass unit. Okay, so what that means is now I can see that what 6.9409, which is you find out in the periodic table, and that's an average for a lithium, is based on the natural abundance. So the 6 lithium has a natural abundance, let's say X, and the 7 lithium, which is shown up here, and the 6 is shown up here, has a natural abundance of 1 minus X. And X is essentially natural abundance of 6 lithium. Okay, so and then this equation becomes 6.9409, and 6 is this number here, 6.015121 times X. 7, which is a 7.016003 times 1 minus X. And then you can solve it for X, and you will find out the X is 0.0752. And then this is, if you're looking at the number of significant figures, that's ended up closest to the numbers. Okay, and then this is number shown up B is the closest one in the multiple choices. So I will choose the B as my correct answer to be here. Okay, number 9, and let's look at that. There is a sample has a mass of this, and after the chemical reaction, the mixture has a mass of this with these errors. Okay, so this is a plus minus, that's an error, and there's a plus minus with this error. So what you find out is the mass before and after the reaction, the mass does not change. This is which is known as mass conservation in the closed system for a reaction. So it's a mass conservation of reaction in a closed system. So okay, if your reactor is closed and then there's no atom disappeared while leaving, so they will be essentially maintain the same mass. So the mass in an enclosed mixture, which is a closed system, is constant. So mass conservation, and the E is the answer. Number 10 is also, let's look at that. There is a mineral sample. It's just sample. The people measure the density using densitometer, and then they find out, okay, so these are the 5 different numbers using this instrument that can measure the density, called densitometer. And then independent study actually say that, okay, the actually true value is this one. And then they are which one is correct about the previous measurement here. And when you start to see this, the word coming about accuracy and the precision repeated many times, and obviously they wanted to know about what's the difference between the accuracy and the precision. So I'm going to draw a little diagram here, okay? And so let's see. If I have this measurement as a bull mark, okay, bullet like a bullseyes, and there are cases, let's say, where the measurement represented here, and these are the measurement that is essentially very reproducible, right? Reproducible. And that's a kind of common languages, but this is related to the precision. But you are essentially aiming not to the true value, but just the measurement is very repeated and very precise is the meaning of this. Whereas this one for here, let's say measurement might be scattered, but if you're looking at the average of these measurements, and you'll find out this one is actually quite accurate, or we call the close to the true values, right? So that's an accuracy. Okay, so these are the two things that you have to know, and the precision is once again is a reproducibilities. And if you're looking at this numbers measurement, what I can do is I can take these 5 numbers and I can do the average. If you're looking at the averages, just add it up and divide by 5, you will get this 3.75 gram per cubic centimeters. And then 7.5, and then I can put an extra one, that's an extra digit that you can think about giving you a calculator, can give this number to you. At any rate, this average number is same to the true values. So we are looking at pretty much the case where the measurement average value giving you the same number as the true values. But if you're looking at actual individual numbers, 3.7, 3.4, 3.8, so numbers are scattered all over the places. So this is more likely this case. This is an accurate, but actually not precise, right? So that's therefore the answer is it has a greater accuracy than the precision. The D is an answer. So in other words, this measurement is accurate, but not so precise. Okay, I guess the definition of reproducibility is somewhat subjective, but I think we're trying to say you want you to differentiate the difference. We want to know the difference between the precision and the accuracy here. So the answer here is a D.